Okay, question 10 is about electrochemistry, and you've got a table of data. There's actually a mistake in this table of data, which was important in the exam, so I had to miss off one of the questions. So the mistake is that I've got iron 3 plus there going to iron 3 plus, and it should actually be going to iron 2 plus there. So the question in this exam was 10.3, which was you could use that as the data question, so they didn't do that one in the actual exam. We're going to skip that one out as well, but it is worth you doing some revision on writing conventional cell representations. So 10.1 is fairly straightforward. Deduce the oxidation state of nitrogen in NO3 minus and NO2, sorry, not NO2, NO. And to do that, you just need to follow the oxidation state rule. So oxygen is going to be -2. I've got 3 of them, so that gives me -6 in total. I've got a total charge on my NO3 ion of -1 or just minus. That means my total nitrogen is going to provide 5 positives, leaving me 1 negative once I add it to those 6 negatives from the oxygen. So nitrogen is going to be +5 in NO3 minus. And in NO, it's going to be just dead straightforward, +2 for the same reason. So I've got no overall charge, so -2 from oxygen, +2 from the nitrogen. The next question, state the weakest reducing agent in the table. So what I'm looking for here is I'm looking for the highest positive number, and I'm looking for what's on the right hand side of that. So that is +1.36 for the chlorine going to chloride. So chloride is, or chloride ions are my weakest reducing agent, and I've got to have chloride. I can't have chlorine. I would lose the mark if I put chlorine. So it's got to be chloride. Okay. So the next question says, use data from table 4 to identify an acid that will oxidize copper. Explain your choice of acid. Use these data to suggest a possible equation for the reaction. Calculate the EMF of the cell that has the same overall reaction. 4 marks. I've got to do 4 things for this. So I go back to my table and I just have a look at what I've got in my table. First of all, I'm going to find the copper. It's got a electrode potential of positive 0.34. I've got something down here that looks like sulfuric acid. That's more negative than the copper. So what you've got to remember here is negatox. The most negative value that I choose for my electrode potentials is going to be oxidized. So this one, sulfuric acid, isn't going to react with the copper because copper is more positive than it. So I need an acid that's more positive. This one's just hydrogen, so which is 0, so that's no good either. Then the only other one that I've got here is this thing here that looks like to me like it's nitric acid, HNO3, and that is more positive than the copper. So that means that if I react these two together, the most negative one, i.e. the least positive one, 0.34, is going to be oxidized. So I found my acid that is going to react, and I've also got my explanation for that as well. So I can say nitric acid, and I can say because the electrode potential of my nitrate is bigger than my electrode potential for my copper 2+. Okay, so I can do, I've got my acid, I've explained my choice of acid. I could go further with my explanation to say that so my copper will be oxidized. I don't need to, the mark scheme says that I've done enough just to state those 2 things. So I've got 2 marks for each. I'm going to do next, I'm going to do the easy bit. I'm going to calculate the EMF of the cell that has the same overall reaction. So I need to do the overall EMF of the cell is the reduction, take away the oxidation. There's lots of different ways of remembering this. Okay, reduction, take away oxidation, or redox. So the cell that's going to have reduction happening is the NO3 minus cell, which was plus 0.96, and then my copper take away plus 0.34 gets me positive 0.62 volts. So that gets me my third mark, and then I'm going to have a go at my next one. Use these data to suggest a possible equation for the reaction. So what I need is my copper being oxidized. So I'm going to write that the reverse way to the equation I've got in my table there. So all of the half equations, remember, are written showing reduction, gain of electrons. I know that my copper is going to be oxidized, so I'm going to write it the other way round. So I'm going to write that here, copper going to copper 2 plus those 2 electrons. And then I'm going to write out my nitrate or my nitric acid in the same way it's written out in the table, my reduction, which I've got up here. 3 electrons makes NO plus 2 H2O. So what I've got to do to make this work is I've got to look at the number of electrons that I've got in both my half equations. So I've got a 2 and a 3. I need to make them equal each other. So to do that, I need to times this equation by 2, so I get 6 electrons, and this equation, the top one, the copper one, by 3, so I get 6 electrons. So if I do that, I'd get 3 of those, and I'd get 6 electrons. If I do this one, I'd have 8 hydrogen ions, I'd have 2 NO3s, I'd have 6 electrons, I'd have 2 NOs, and I'd have 4 H2O. So my electrons now balance, and what I can do is I can write that out so that I've got all of the left hand sides on the same line as each other. So 3 coppers plus my 8 hydrogens plus 2 NO3 minus, making 3 copper 2 plus 2 NO plus 4 H2O. I could write on my 6 electrons on both sides, but actually they would just cancel each other out, so I would leave them off. And that's my final mark, my 4th mark for that question.